Here we have a problem on logarithm, that is we have to solve for x in the equation over here. Okay, in my first step what I'm going to do is I'm going to assign a new variable for the exponent we have over here, that is for this log x to the base 3. I'm going to assign a new variable y, that is let log x to the base 3 equals to y. Okay, now in this equation I'm going to solve for x. Okay, so to solve for x, what I have to do is I have to convert this equation to exponential form. Already this equation is in logarithmic form. To convert this equation to exponential form, we have to consider the stuff on this equation which contains logarithm. So the stuff on the left side over here contains logarithm. In this stuff, I have to consider particularly the logarithm along with the base 3. So now to convert this equation to exponential form, I have to move this logarithm with base 3 to the right side of the equation. When I move this logarithm with base 3 to the right side of the equation, I have to ignore this logarithm and I have to consider only the base 3 on the right side of the equation. The value which already exists on the right side will become the exponent of this base. On the left side, I'm just taking this x as it is. Okay, now let me go to the equation over here. There is x to the power of log x to the base 3 equals to 9. Let me write the equation over here. X to the power of log x to the base 3 equals to 9. Okay, now what we can do is we can plug in this 3 to the y-th power for x over here, because 3 to the y-th power equals to x. So for this x, we can plug in 3 to the y-th power. And for this log x to the base 3, we can plug in y. So that's what we have assigned, because we have assigned the variable y for this log x to the base 3. So for this log x to the base 3, I can plug in y equals to 9. Okay, here we have base 3, we have exponent y, and for the complete stuff, we have exponent y. So whenever we have two exponents like this, what we can do is we can multiply the two exponents. When I do so, y times y is y square. I'm getting 3 to the power y square equals to 9. Okay, now let me continue over here, 3 to the power of y square, and this 9 can be written as 3 square. Here, two terms are equal with the same base, 3. Whenever two terms are equal with the same base, what we can do is we can equate the exponents by 1-to-1 property. So then I'm getting, when I equate the exponents, the exponent on the left side is y square, the exponent on the right side is 2. I'm getting y square equals to 2. Okay, now let's solve for y in this equation. So for that, we have to get rid of this square over here. So to get rid of the square, I have to take square root on both sides. Let me do it. So when I take square root on both sides, usually we consider positive or negative sign for one of the square roots. So usually we consider it for the square root which contains number inside. So this square root contains number inside. We can consider positive or negative sign for this one. On the left side, the square root and square will cancel out. Then we get y equals to positive square root of 2, and the other value of y is negative square root of 2. Because here we have positive or negative square root of 2, we can split up this solution into two parts. Y equals to square root of 2 or y is equal to negative square root of 2. Actually, my aim is not to solve for y. Actually, the variable y is taken by us. So it has to be replaced by the original stuff. What is the original stuff for y? So we know that y equals to log x to the base 3. So we can plug in that log x to the base 3 for y over here and here. Then I'm getting log x to the base 3 equals to square root of 2. And in this equation, log x to the base 3 equals to negative square root of 2. Okay, my aim is to solve for x. For that, again, now we have to convert this equation to exponential form. For that, we have to move this log with base 3 to the right side of the equation. The same thing we have to do over here. When I move this log with base 3 to the right side of the equation, as I said over here, so we have to ignore this logarithm and we have to consider only the base 3 on the right side of the equation. The value which already exists on the right side of the equation will become the exponent of this base. On the left side, we have x. So x equals to 3 to the power of square root of 2. This is the solution I'm getting from the first equation. Now let me go to the second equation over here. So when I move this log with base 3 to the right side of the equation, let's ignore this logarithm and let's consider only the base 3 on the right side of the equation. And the value which already exists on the right side of the equation should be taken as the exponent over here. That is 3 to the power of negative square root of 2. On the left side, we just have x. Okay, I have solved for x in the given equation. I got two values for x. One is x equals to 3 to the power of square root of 2, and the other value of x is x equals to 3 to the power of negative square root of 2.